All right, next on stage is our wizard, Mike Leonard. He's a Python and Django developer for a couple of years now. He worked in the public sector for the last years and, well, has spent or recently moved over to Reposite Power using Python for just about everything, and probably also a bit of wizardry. Let's see what he's going to teach us today.
Thank you all for coming. So today we're going to talk about metaprogramming specifically within Python. The idea here is not to make everyone go home and be metaprogrammers, because that's probably a horrendous thing. We don't want that. But the idea is to teach you how Python can use some of these things in Python and give you a better understanding of perhaps how Python works internally and some of the things it can do that you maybe didn't know before. So let's start off with a quick question and answer type thing. I know everyone loves participating. So what is this in Python? String. Simple. So the type of that is a string. Great. What about this? Yeah, int. Fine. Great. What about the type of int itself? Type. Yeah. Type of object? Oh, it's getting a bit harder. Type as well. What about if we look at the class of int? Does anyone know what the class of int is? Oh, type. Yeah, type as well. OK, what about the type of type? Oh, I gave the answer away. So the type of type is also type. I think there's some magic going on in the C implementation of Python and binding that up. And no matter how many times you do type of type of type, it's always going to be type. Type is the top level thing, and you can't go any higher, and it's magical. OK, so now if we define a class, we've got class person, nothing in it. What is the type of this? Oh, good. So in Python 2, we end up with class obj. So suddenly we've broken our lovely type hierarchy with type at the top. So this is Python 2, and this is the old style class. In Python 2, we can define new style classes as well by inheriting from the object. So object is a type, as we saw. So we look at type of person, we can see that the person is now a type. So these new style classes, these are default in Python 3. In Python 2, you have to extend from object to make it a type. But these new style classes are fantastic because they keep everything in this type system and everything remains a type. And types are wonderful and fantastic. So old style classes again in Python 2. We instantiate a person class to P. Does anyone know what the type of P is? No. Type of P in old style classes is instance, which isn't very helpful. We've got an instance of something, who knows what. That's not very good. But if we do the same thing in new style classes and the Python 3 classes, we get a nice concrete type. We say P is a class person, which is fantastic. So we've got this great type hierarchy sort of thing going on in Python. Really simple to use. Everything's kind of as you expect, unless you made a horrible mistake of using old style classes and are still on Python 2. And similarly, we can get the class of P, and that goes back up to type. So again, we're still in this type system. Everything's a type. So that's bad, wrong, incorrect. If you're still using Python 2, same applies, bad, wrong, incorrect. I'm stuck on Python 2, so I'm bad, wrong, and incorrect. New style classes, default on Python 3, fantastic, wonderful, concrete type system. So type is awesome is the takeaway from this. So we now understand that everything in Python is a type. Up and down the hierarchy, we have these great classes that kind of go up to types. Instances go classes, types. Everything's a type. So we're happy with that. Everyone's comfortable. Everything is a type. Now we want to prove that everything is an object as well. So absolutely everything in Python is an object. Even classes are objects, functions are objects, everything are objects. So here we define a class person, which extends from object. We assign it to P. And even though it's like an instance of some class, we can see that we can assign properties kind of like you expect. You're used to. You can arbitrarily dot whatever you want, put something into it. Everything's nice and happy. You can set those values and retrieve them. What you can't do, again, as you'd expect and probably know, you can't just try and access an arbitrary property that doesn't yet exist. You'll get an error saying it's not yet defined. So that's fine for objects, like we've instantiated P from this class. What about a class itself? So we're trying to prove that classes as well are objects. So we can see we can basically do the same thing. We've got a person class here. We're trying to access age, and we get an error, just like we do when we had a person instance object. So these are behaving very similarly. Same thing again, we can, on the person object itself, we can define an arbitrary property. We can set age to 35, person.age is 35. So these classes themselves are behaving just like the instances we had. So we can also we can instantiate versions of these classes. So we've got person 1 and person 2. We can still assign an arbitrary property on the person class, and if we kind of access that property on the instances, you can see it floats up to the class, and in both cases they've got foo is bar. So the objects kind of pretty much work how you expect. This sort of hierarchy inheritance stuff is working pretty much as you expect. Everything is an object. So just like types, and types are awesome, objects are also awesome. And the whole hierarchy in Python uses types, and everything is an object. And these are two things that I think sometimes get a bit lost. People don't necessarily know or understand, but it's good to keep in mind. So everything in Python is an object. Everything follows a type hierarchy. As we saw earlier, there was some magic going on with type, where type of type is type. Also, more magic with type. If you try and do, so I just said everything's an object, you can assign arbitrary properties. If you try and do this on type, you can't do it. So type behaves differently because it's important and special. So why is type important and special? And that's because type is a meta class. And importantly, in Python, type is the default meta class. That's what we're going to talk about next. So what exactly does that mean? That basically means type is this magical class that can be instantiated in some way. It's an object like everything else. It can be instantiated in some way, and what you get from that back is basically a new type. In this case, a type that's a class. So what we're doing here is the first line, we're defining basically exactly the same as what we saw before. We're defining a class called person. That person class is going to extend from object. And we're giving it some arbitrary kind of initial properties of foo is equal to bar. And to prove that kind of this syntax is working for creating a class, in the next couple of lines, we're defining a sub-person. I don't know why I called it that. But we're defining this sub-person, which is a subclass of person. Doesn't do anything. You can see we can do subperson.foo. We get access to that foo bar. The whole thing worked. So now we created this whole new class called person, and we haven't used the class keyword at all. So this is kind of hopefully proving to you that everything's just an object. And this class sort of syntax in Python is syntactic sugar. And really we can define classes in other ways by calling methods and things that are more common in Python. So what does this type thing look like? So type itself is a class. Extend some object. This is basically copied and pasted kind of from the standard Python definitions. And you can see there it's got an init method. And the init method is a class method. It defines what, bases, and dict. The what is the name of the class, so person, subperson. The bases are what it extends from. And in Python, we can do multiple inheritance. So this basis can be a tuple of multiple superclasses there. And the dict is kind of your initial list of properties on that class, and it's just a straightforward dict. So in that previous slide where we were using type sort of as like a function call, we're actually instantiating a type object, passing these things to it. And there we can see the exact example where we've got person as what, object as the bases, and foo bar as the dict. And that's basically exactly equivalent to this. So now we've got this dynamic way in code of creating brand new classes from nothing without having to define this class syntax. So to try and sort of talk about meta classes now. So I said type is the default meta class. So what the meta class basically means is every time I create a new class, how do I sort of instantiate and construct the class itself? And the meta class is the class that creates classes, if that makes any sense. So to kind of show that here, I've defined some meta class. Now meta class should extend from type. So I've got a new meta class here. I've got an init method in there. And in that init method, I've got the same signature as we saw with type. And in there, I'm just printing with an uppercase P, because that's how Python prints. I'm printing it in some meta class that we're in that method, so I can see it. And then beneath that, I'm defining some new class. And because this is defining the class, the meta classes create classes, not instances. The moment I create that new class called some class, I've defined its meta class to be some meta class. It goes off, it calls that init method, and comes back. And we can see that init method being called there by the print statement printing out. Is everyone keeping up? That's kind of weird. There's some nods, so I'll take that as a universal nod. So why do we care about any of this? Why is it interesting? Doesn't it seem really, really confusing and silly and nonsense when we can just use the class keyword and keep everything normal? Yes, that's correct, and that's what you should continue believing. But there are some cases where I think it's quite interesting to see how libraries and stuff do use metaprogramming for the power of good rather than the power of horrible code. So one place that I think uses it particularly well and really efficiently is in Django. So just quickly, show of hands, how many people know Django? Okay, cool. So that's a reasonable amount of people. So in Django, there's an ORM, object relational mapper, for dealing with database interactions. And you can kind of create tables, you can query tables, you can do all sorts of stuff, basically by using plain Python objects. And it's probably the greatest ORM in the world. So one of the things it does is it has this amazing way of defining a model, so your table basically in the database. And here's an example here. So I've defined a person class, which extends from Django's model class. On that, I've given it a single field name, and I'm saying this is a char field, so just some text, and it's got a max length on there. So very much a regular Python object. Now, interestingly, if I do type myModel.name, that should be name, what we get back is this deferred attribute class, which clearly doesn't match the char field we're seeing above. So to start with, this starts looking a bit weird. We define a char field. What it actually is a deferred attribute. Things get even weirder if we create an instance of this class. So we now create an instance of myModel. We do m1.name, and we get an empty Unicode string. And if we do type of name, we get type Unicode. So now we define something as a char field. On the class itself, it's actually a deferred attribute. And when we instantiate that class, we get Unicode. So as things start seeming pretty crazy, and how do we get here? If we take a look at the model class in Django, what it's actually done is this top line here. And if we take a look at that, it's using 6.with_meta_class, which is basically the same as the syntax earlier I used with the __ meta class. 6 helps with like Python 2 to 3 compatibility, so it's just a different way of doing the same thing. And it's saying the meta class of model is model base. If we take a look at model base, what model base does is define an __ new method. Now the new method is used for creating new objects. So one common misconception with Python, particularly for those people that come from other languages, is that __ init is the constructor of a Python object, which is not really true. __ init is the initializer of a Python object. By the time you get there, the object has already been constructed and created. And the method responsible for doing that is __ new. So kind of new's role in the Python lifecycle is to create the new instances of a particular class. So we kind of take a look at the gist of, whoops, oh, and there's the same thing again. If we take a look at the gist of what that Django model does, this is kind of pseudo-codey-ish of its new method. But essentially, so we saw model base, the meta class itself, extends from type. So the first thing it does is call super, so it calls types constructor, which returns you this new type, this new instance. We get this new class here. And basically what we say is for all the attributes passed in, so we had like foo bar earlier, so in this case like the name char field, for each of those attributes, loop through them and call setAttar on this new object we just dynamically created to populate those fields. So what that's basically doing is saying, okay, cool, I've got a char field here. When I instantiate this person class to an object, I'll take that char field And I know that shark field should be a Unicode method, so I'll use setAttar, and on the new object I've just created, make that a Unicode field. So taking this sort of abstract-y char field type to a concrete kind of primitive. So what is setAttar? There's a few helper methods in Python. There's getAttar, setAttar, and hasAttar. And these basically take in an object of some kind, and a string being the property name you're interested in. getAttar will return you the value of that object, or the default if it's not there. setAttar can set any dynamic property on an object, and hasAttar will return true or false depending if that attribute exists. So now we've got these dynamic ways of setting and retrieving attributes and checking if they exist. So that kind of brings us to a point now where we can create brand new classes dynamically, we can set properties on them dynamically, and we can see an example of how Django uses this to build these instances that are easy to work with based on kind of some essentially metadata you use to describe how that model should look. And just to reiterate this, just kind of remember the object lifecycle works with __ new and then __ init. And for the most cases, you don't need to worry about new. Don't go away and start putting all your code in new. Bad things will happen. Keep using init, but it's interesting to know. So that brings us on then to method resolution order. Method resolution order is to do with when you have a hierarchy of classes, how does Python go through and figure out which method to call based on if you're in a subclass, you need to go up that tree and figure out where the method is and invoke it correctly. So here we've got an example of new style of classes. We've got an animal at the top of the hierarchy. We've got a dog, which I guess is a sub-animal. And we've got a Labrador, which is a sub-animal, but the hierarchy goes animal, dog, Labrador. And on that, because it's a new style class, or in Python 3, you can do __ for method resolution order, and that will return back this tuple in the order in which it will look up methods when you call them and properties and that sort of thing. So if we were to call like bark, for example, you would first of all look in the Labrador, then in dog, then an animal, then finally in object at the top of the hierarchy. Now, if we compare that to how it used to be, again, with old-style classes, so it's the same thing basically, but animal doesn't inherit from object, so it's an old-style class. We don't have MRO, for starters. And also we get kind of this here as well. So we got brief example with A, B, C, D. The hierarchy of D extends from both B and C. I'll show you a diagram in a second. But you can see that, so D's immediate parents are B and C. And you can see that C defines this foo method. So kind of if you call foo on class D, you kind of expect it to go to its immediate parents and find that foo somewhere. What you'll see with these old style classes is actually we're in A, it's gone right to the top. And to show that a bit clearer, we've got a basic class diagram here. So we're calling foo on D at the bottom, but the one it's actually invoking is the foo at the top on A, which I'm guessing to most people should seem a bit weird, why it's kind of jumped one that's directly above. This is a lovely feature of old-style classes, and if you're stuck in Python 2, every now and again you'll forget to do like bracket object when you're creating a class, and you'll invoke something, and it will call a function you really don't expect, and you can't for the life of you figure out how it's getting up in there and why it's ignoring C and all this sort of stuff, and probably the chances are it's going to be that you've forgotten that object thing at the top, and it's using old style method resolution. New style, same thing again, but you can see we've got object at the top, and when we do d.foo at the bottom there, you can see it prints in C. I think that's much more logical and how you'd expect it to work. So that kind of really whirlwind tour of new style classes, how they work, the type system, method resolution order, a brief example of how all this magic stuff with metaprogramming works in Django. And types are awesome. The new type system's great. Everything's an object. It's all fantastic. So now what we're going to do is move on to descriptors. So there's another part of Python, which I don't think gets used that often. Again, used really, really well within Django, and we'll see another example of that in a second. But descriptors are basically a way of controlling when you set and access properties. So what you can see here is I've defined a class. I put on it a type called SumString. I instantiate that class, and I just use straight old equals, nothing special there, to make that SumString equal to hello PyCon. And if we print it, we get hello PyCon backwards. So the interesting thing here is we're doing a straight up equals. And so what you normally expect is, regardless of what you defined reverse string as above, you'd expect that type there, SumString, to be overwritten with a straight up string or Unicode or whatever. But actually somehow it's reversing it. And similarly, we can do the same sort of thing on instances as well. It's got instance of my class. They're defined to this reverse string. We can set them in both places. Every time we print it, it reverses the string. So this is working on instances rather than classes themselves. And this sort of magic's happening again. So how does that work? Well, a descriptor requires you set two magical methods, __set and __ get. Set takes in a particular instance or object and the value you want to set on that thing, or set that object to. Get takes in the object itself and how you retrieve that object, basically. So we take a look at the example of the reverse string. We just define set and get on there. So when we're setting the instance somehow, we're setting some property to the value and then retrieving that value later on and doing the common little Python thing to reverse that string. So when we're doing the equals thing, and when we're printing that property and accessing it, it's actually going in and using set and get rather than the normal defaults. So again, why is that interesting? It just seems like, again, nonsense on the face of it. But we can start doing clever stuff, by, for example, having tighter defined types. So perhaps you want something to be a small integer rather than any integer. So we can take this set here and we can say if the value coming in is greater than 10 when we do an equals, we can raise type error, otherwise we can assign it. And similarly, we can return that type if it was all said and okay. So we can start doing additional validations. And here's an example of an action. So we define this small int. We try to set it to 99 just using the regular equals syntax. We're not calling any magical methods ourselves. And we get this error saying it must be a small int. But if we try and set it to 3, that works fine. So that's an example of kind of using it for type validations, but it can be used for any number of things. So earlier we saw in the Django world, we saw this deferred attribute. Now what a deferred attribute basically is a kind of a lazy type attribute. So when you can define this model, you can put on it this particular property, and you can say it's a deferred attribute. And these are usually used within the ORM for fields in the database. So rather than, perhaps we've got some bad code, you've written an object or a particular code path, you constructed an object, but you don't ever actually use it for some reason. Going to the database, running the SQL, getting the data back could be a slow operation that would be completely unnecessary. So what Django does by default is create these deferred attributes. So when they're accessed, on the first access, it goes to the database, retrieves the information, and then caches it, and all other accesses look it up in the cache. So this means it doesn't have to be looked up until it's actually used, and once it's looked up once, it doesn't have to be looked up again. So these are great performance optimizations, and kind of the gist of what the deferred attribute does is define this get method. So it retrieves and caches the value on the first lookup, otherwise it returns the cached value. And kind of the pseudocode for it is basically if the value is none, then look up in the database, and then just return the value itself on all other occurrences. So that's kind of descriptors, again, really whirlwind kind of tour of what they are, but they can be great for doing this additional control, performance reasons, type checking, that sort of thing. The Python documentation says that a descriptor is an object attribute with binding behavior, one whose attribute access has been overridden by methods in the descriptor protocol, which doesn't really mean anything to me. But it's basically, they're cool magic stuff, and you can assign and retrieve things magically. Oops. So just really, really quickly, there was a talk yesterday, I believe, on a whole load of other magical Python functions. There are just loads of them, some of which I've used, some of which I have no idea what they actually do. But they're in documentation at that link there, and I recommend you go and have a play. They're pretty interesting. But you can override pretty much everything Python does by default. There's like radd, add, iadd for just when you plus things together, it will fire these functions to decide how they should be added. So you could add like a person and a sub-person and get some other type of person. You could multiply people, you could negate people, which is like the unary operators. You can convert things to ints, floats. Enter and exit are interesting with the, I forget what they're called, context is it? Where you like go with such and such and go into it. These get called for sort of clearing up state and things. In Python 3 is also prepare, which I've not used, but I believe that's to do with setting up initial properties of an object, kind of called around the same time as new in it. So there's a whole bunch of things in there that are all fantastic you can play with, and you can do some truly horrible things to just ruin your code. Which brings me to this. This is my big warning now. So this all seems fantastic and fun and great, and Django's got some great examples. But please don't now go away and think, oh, this is nice, I'll try it out, think it's cool, and decide to use meta classes and meta programming for everything. It's pretty much never a good idea. When doing some research for this talk, I kept coming along loads of other people that had talked about meta classes and blogs, slides, all sorts of things. And pretty much everyone quoted this, so I felt I had to as well. But basically, yeah, don't use them. They're just no need for the most part. If you're building an ORM, go for it. That sounds fantastic, but I'm guessing most of you aren't doing that. And they just lead to just horrible spaghetti code where you construct some class, but actually returning you something completely different. And they're truly fascinating and interesting. Definitely play with them. If you use Django a lot, definitely take a look through the Django source. Django's got a beautiful code base with fantastic use of this stuff, and it does it really, really well. And it's, I think, the correct thing for Django to do. Take a look at that stuff, see how it does it, and just have a better understanding of Django. It's really useful for that. And that's everything. Thank you very much.
Thanks, Mike, and thanks for the compliment on Django. We got a couple of minutes for questions. Somebody from an underrepresented group, maybe as the first one, opening the session. Anybody?
It's too late in the day. Everyone wants to go home.
All right, somebody else with a question.
Oh. One person wants to stay.
Does that work? Yeah, there we go. In the code example from before with the method attribute overriding, you had instance. Is that just magic inside
No, that was
class?
a typo. Again, I was hoping no one noticed.
Okay.
It should have been. It should have been object. I noticed. I was going through the slides a minute ago, and I noticed it didn't match the documentation. And I thought to try and tidy it up, I'd use the same signature as the Python docs, and I forgot to change the bodies. So well done.
Somebody else?
Ignoring your warning of never using these, besides using them for an ORM, when else is a good chance or example to use them?
I honestly don't know. I've been Python programming for a while now, and I've never had the need to use them in my own code. I started on this exploration because of Django. I was like, how does Django go from like defining this char field to kind of being just this primitive Unicode type that I can interact with as if it wasn't this char field? I don't have to care, yet somehow that gets in the database, validates all this sort of magic. So I went on this wild journey into reading through the Django source, and kind of discovered stuff that way. But I've literally never needed to use them. I think it's a pretty rare case you do. But I think it's good to know as a Python dev just to understand how Python works.
There's one more. Maybe last question of the session.
I'm going through a similar sort of situation at the moment with sort of whiskey and everything, like learning it from, I guess, first principles. How long did this take you to sort of go through and understand it?
I mean, it started 5 years ago and it's still going on now, I think, is probably... I mean, it's like a never-ending cycle. Like, to get the basics, I think it's pretty quick. I've not looked at the WSGI source, but for Django, the source is very clean. It's very well documented, and it's really quite easy to get into and take a look at. So understanding the basics is I think, really simple. It's worth a look. You know, if you've got a good idea, you can kind of follow through the links, chain up the classes, and see what's going on there. But it's a big code base. Not all areas I use or have looked at, and I constantly try and look. I think generally as a principle as well, I think if you use a library or a framework extensively, I think just trying to take a few minutes to look at the source and understand better what's going on makes you a better dev at using that code base. You understand like why it's doing things, exactly what it's doing. Sometimes you can find ways to circumvent things you don't like in it as well, which is also bad, but helpful.
All right, thanks, Mike.
Thank you very much.